Hello students, I Professor Varsha Patil welcome you to the video lecture series for the course titled Data Mining and Data Warehousing. We are learning first unit as per the curriculum prescribed by university, and we were learning topic data pre-processing techniques. And today's is second lecture for topic data pre-processing techniques. In earlier lecture, we learned what are the issues with real world data. We also learned how do we define data quality. We learned the two techniques, that is data cleaning and data discretization. And in this lecture, we shall be learning about one of the data pre-processing technique, that is data transformation, which includes normalization, and three techniques for normalization: MinMax Normalization, ZScore Normalization, and decimal scaling. Data transformation, that is one of them, that is normalization, may be applied where data are scaled, data that is scaled to fall within the smaller range, that is 0 to 1. And this improves efficiency and accuracy of data mining algorithms. We shall learn how. So topics which we shall learn are these three core topics: MinMax normalization, ZScore normalization, and decimal scaling. First one, let us understand what is transformation. And we are learning it with respect to attribute transformation. So attribute transformation is a function that maps the entire set of values for a given attribute to a new set of values. And when we learn transformation, it could be in multiple forms. Let us look at few examples. If data source has employee ID as one of the object identifier with three attributes, name, age, and salary, then we may extract only employee ID and salary by dropping the other two attributes. This is also transformation. We may filter out all such records where for those records salary is not present. That is, while filling up the information, salary values are not filled in. So wherever salary field is empty, we may filter out all such records. The other way could be we may derive a new attribute or a value from the existing values. Like we may have two attributes, one as a quantity sold and other is unit price of that particular item, and we may compute the third attribute, which is total amount against this sale. We may sometimes summarize multiple rows data, that is adding up all the salaries to find out how much is the salary, total salary for particular month. We may sum up for each sales region how much is the item sold for particular area, particular region, or particular shop. This is termed as aggregation. We may split one column into multiple, that is one attribute is separated to generate more attributes. Like we may have date field with month, date, and year, and we may generate three attributes, one for date, one for month, and one for year. Data which we transform is said that it is ideal for mining it. Sometimes the data in its actual form is not ready for processing, and we need to pre-process it. One of them is transformation. So it is a process of converting data from one format to other, is nothing but data transformation. Data transformation could be simple or it could be a complex based on the required changes in the data, that is from source to the target. And data transformation includes multiple activities. There are a range of activities. We just saw in multiple examples that we may convert the data time, we may cleanse it, we may remove duplicates, we may remove nulls, we may try to enrich the data, we may perform the aggregation, we may derive a new attribute, and so on. In this table, we have listed the attribute types, that is nominal, ordinal, interval scaled, and ratio scaled. And then this is a type of some kind of transformation, and this is what can happen with it. Let's look at nominal. Nominal, we have learned that it is just some names given to, and there is no ranking as such. There is no order for the nominal name. Say colors. Colors could be red, blue, green, and so on. So when you list it, they are not forming any particular order. Similarly, it could be an employee ID, or we may have names which are identifying the object. And if we perform some permutation, that is, we reorder the values, then we have to see whether it is going to make any difference or not. Similarly, when we have some ordinal value, we have to look at, say, a rank of the students, first rank student, second rank, third rank. And if we replace them with some newer values, say by dividing by 2, so 1, 2, 3 becomes 0.51 and say 0.33. Then will it make any difference? So you have to, when you perform transform, you have to always look at which kind of attribute you are working on, and the transformation or the process which we use shouldn't make a difference in the sense that it shouldn't change its relevance or the meaning. So we have few strategies for data transformation, and these data transformation strategies are listed as smoothing, aggregation, discretization, attribute construction, generalization, and normalization. And in today's lecture, we shall be learning about normalization and discretization. Let us learn in brief what are these data transformation strategies. Smoothing is removing noise from data. And we have learnt in earlier video 1 how do we smooth data and how do we remove noise from data. We have learned replacing the values with mean or median, mode, and so on. The other is attribute construction. Here new attributes are constructed from existing one, like from date field, where all the three values date, month, and year, we can have three different attributes for date, month, and year. In aggregation, it could be summation of all the values in particular row, sum of all the cell to find out how much is the sale for a day, how much is the sale for the month, and so on. Normalization is scaling from one range to the specified new range. We shall be learning it. Discretization transforms continuous data to small intervals. Let's say we have employees and their age is ranging from 22 to somewhere around 58. We can group them into three. From 22 to 30 we can say that these are youngers. From 31 to 50 we can say these are adults. And from 51, 52 onwards till 58 we can say that these are elders. That is discretization. And in generalization, it converts low level data attributes to high level data attributes using concept of hierarchy. And in this video, we shall be learning about normalization. Now, what is data normalization? Data normalization involves converting all data variables from one range to the new given specified range. Popularly, normalization process, all attributes are transformed or scaled, we can say, to fall in a smaller range, which is -1 to 1 or 0 to 1. And you will see that in literature, most of the times it is a range of 0 to 1 is selected. When attributes are in different ranges or scales, data modeling and mining becomes difficult. And to make the process easy and accurate, normalization is used. And normalization helps in applying data mining algorithms and extracting data much faster way. So let us learn data normalization. In data normalization, there are many techniques in literature you can find, but the popularly used techniques are these three, and these are part of your curriculum too. So we shall be learning these three, of which let us start with MinMax normalization. MinMax normalization is required to scale various data in the same range, and typically it is a small range. The simplest normalization technique that fits data from predefined range to, or we can say from earlier range to some new predefined range, or you can say in predefined boundary like 0 and 1. And it is said that this is the best suitable range which is known. So MinMax normalization performs linear transformation on original data. In MinMax normalization, we have some original data, so we have earlier range. That is, we have minimum for the earlier values and we have maximum in for the earlier values. And we use it with the help of new max and min to compute new values. So let's consider A as a numeric attribute with some n observed values as say V1, V2 up to Vn. And say mean A is earlier minimum for the earlier range of attributes and max A is maximum among these attribute values. Now we are going to map each of these values to new range. Say V is the earlier value and we want to compute its newer value, that is V dash. And new range is same, new min A to new max A. So we compute this V dash using earlier V as V dash is equal to V, that is earlier value, minus earlier minimum divided by range, that is computed using max A minus min A, earlier range, into new range, that is new max minus new minimum plus new minima. And using this formula, we are going to compute each value of this attribute A. That is for V1, V2, Vn. For each one, we are going to substitute in this formula and compute a new value which will range in new minimum to new maximum. Min-max normalization, do remember that it is not going to change the relationship between the original data values. It will preserve the relationships. It may encounter out of bound error if a future input case for normalization falls outside the range which we planned or which was existing. So this is our formula. V dash is equal to V minus min A divided by max A minus min A into a new range computed using new max minus new minimum plus new minimum. And the commonly used range, as I said, is 0 to 1. So if we use the new range, that is 0 to 1, and if we substitute these values, that is new max is 1 and new minimum is 0, because new range which we are going to use is 0 to 1. So this 0 to 1 range, for this range when we substitute values, we get it as 1 substituted for new max, 0 for new minimum, and plus new minimum value as 0, it results into formula which is most popularly used and which is very easy for you also to remember for the range 0 to 1 as V dash is equal to V minus min A divided by max A minus min A. So let's solve one example for min-max normalization. We are given a range from $12,000 to $98,000 and new range to which the attribute is to be normalized is lying between 0 to 1. From this, using our formula, we can compute a new value for a new range for a given attribute value. So our new minimum becomes minimum for earlier range is $12,000 and max is $98,000. New minimum is A and new max is 1. So how do we compute a new mapped value for $73,600? So to compute a newer value for this attribute value, our formula says that subtract value minimum from this. So 73,600 minus 12,000 divided by range, which is max minus mean, that is 98,000 by minus 12,000, and into a range. We need not substitute these values, but even though we substitute, then we get a value, new value computed for 73,600 dollar as 0.716. And you can note that the range which was from 12,000 to 98,000 and one of the values which is mapped to new value lies between 0 to 1, that is 0.716 is the value which ranges between 0 to which lies between range 0 to 1. Hence we say that $73,600 is mapped to 0.716. So let us look at one more example. Here we are given minimum and maximum value for an attribute platelet count, and it is given as 10,000 to 1 lakh. So platelet count may vary from 10,000 to 1 lakh, and we wish to plot a platelet count in a range 0 to 1. We are given a set, that is some observed values for platelet count from 12,980 to 78,900, and we wish to compute a new values in attribute value, that is 0 to 1. Using MinMax normalization, the value 22,000 for attribute platelet count is to be computed. So new value 22,000 for 22,000 will be computed using our formula, that is 22,000 minus 1000, which is minimum value for the range, divided by the range, that is max minus minimum. So it comes out to be 12,000 divided by 90,000, and it results in 12 by 90, a value 0.13. So 22,000 is mapped to 0.13. So we computed for one of the attribute value, that was 22,000. Similarly, we can map each of these values using a formula to new range, that is 0 to 1, and then we can plot platelet count. If you look at this graph, you can see that the red color shows the original values. So if we think of platelet count from 10,000 to 1 lakh, the values were varying. So there were variations and peaks you can find out with the red color plot. When we normalize it to new values, that is 0 to 1, then the plot may look like the one which is plotted with green color, that is sea green colored one. The next type of normalization is Z-score normalization. We are learning three techniques for normalization. The second one is Z-score normalization. This is much easier if you look at formula, because you have to simply substitute the values for mean and standard deviation. And using this, you have to compute a Z-score, that is a new range value. So Z-score normalization, which is also known as zero mean normalization, simply calculates a new value for attribute A based on the two values, that is mean and standard deviation. So value V of A is normalized to V dash with the help of this formula, which says that new value V dash is equal to V minus mu divided by sigma. Here in this formula, generally we are given a population mean, that is mu, and we are given a standard deviation, that is sigma. These are two letters, Greek letters, which are used to represent mean, population mean and standard deviation. And you have to substitute values in this and you get a new normalized value. Here mu is population mean of the feature and sigma is standard deviation of the feature. Z-score normalization is a strategy of normalization that is also used to avoid and to identify the outliers. For understanding data pre-processing, we have to understand few statistical terms. We use statistical measures, central tendency, diversity and data distribution for data pre-processing techniques. In one of the videos, that is statistical description of data, we have learned about central tendency. We learned the terms which are used for computing finding central tendency. Those were mean, median and mode. And we also used them for data pre-processing techniques, which were data cleaning and data smoothing. Today, for understanding this Z-score normalization, we are going to revise the statistical terms, that is standard deviation. So mean is average of set members. Mean gives information about central tendency, but it doesn't help us to find out the distribution of data or variation of data. Mean we learn that mean, one of the mean was population mean and one was sample mean. When we pick up only few samples from the attribute say data set, then we compute its sample mean, or if we are using a whole population to compute an average, then we call it as population. And the standard deviation is a number that measures how far away each number in the set is from a central, that is from mean. We just learned that central tendency helps you to find out where the most of the data is lying, and standard deviation is helping us to find out how far away each number in the set is from their mean. Standard deviation, when we say that standard deviation is large, it means that spread of numbers is large. And when it is small, we say that most of the numbers are closer to their mean. Look at this figure. In this figure, we have values ranging 0 onwards. And if you look at the values, you will see that we have most of the values at center, and there are some values which are at near 5, and there are some values which are between 20 to 25. Few values, one value is more than 25. Now the green line is showing you average, that is we computed a mean of them and it is shown with green line. Red bar, that is red, is showing you range from minimum values, that is from min to max. So when we compute max minus min, it gives you range. So we say that values are ranging from this to this. Just a minute. I'm very poor in using this mouse as a pen. And then we say that this middle yellow color is showing you that this is a center, most of the data is centered around it. For standard deviation computation, we use variance. Now what is variance? Variance of n observations from x1 to xn for some numeric attribute, say x, is computed using this formula. Here variance is sigma square. Variance is computed as sigma square, and square root of sigma is our standard deviation. Now how is this sigma square computed? It is average of. It is average of difference of each value from its mean. What we do at center is, you can see that every xi we are subtracting with mean. So when we subtract mean from every xi, that subtraction we are squaring, and then we are taking sum of them and then average. So we also say that variance is, that is mu square, is average of sum of squared difference of each value with its mean. Here x bar is a mean of these observations, which is a sample mean. When we use mu, then it is a population mean. And we say that standard deviation sigma is square root of variance, that is sigma square. Look at this example. Very simple example. We have three values, x1 8, x2 9 and x3 4. So mean of these three values comes out to be 8 plus 9 plus 4 divided by 3, that is 7. This 7 we compute as average. And then we are computing mu square, that is variance, with taking a subtraction, that is we are subtracting from each value its mean, and then taking its square and adding up all the values and then dividing by 3 minus 1. Now note that instead of 3, that is instead of n, we are subtracting 3 minus 1 because this is a sample mean. When we use sample mean, then it is sample standard deviation, and instead of taking an average by dividing by n, it is n minus 1 when it is a sample mean. So it comes out to be 7 as a variance, and square root of variance, that is 2.65, is our standard deviation. Next interesting term which is to be learned is normal distribution. You must have heard this in statistics. This is very often used to define something where mean, median and mode are same. When we say that the distribution is normal, then mean, median and mode are equal. And we can see that there is a symmetry at center. That is, central tendency is defined using mean, median and mode, and there is a symmetry about the center. When we say there is a symmetry about center, it means 50% of the values lie left to the left side of a center and 50% values lie to right side of center, and this is termed as normal distribution. This is one more term you may not understand, or this is not required for everyone now to understand, but this is very interesting. When we say that distribution is normal, then it forms a bell-shaped curve. This is called as normal distribution, and bell curve distribution of data tends to be around center with no bias to left or right. This is normal distribution. Now what this normal distribution has to do with the thing which we are learning, that is Z-score normalization. Yes, they are related. If we measure in units the size, that is sigma, about the mean, that is mu, we can transform our data to standard units, say some t of the standard deviations from average, and this is called as standardizing. So we are trying to standardize our data, and for standardizing data, the formula which we are learning is used, which is x minus mu divided by sigma. That is, every value, value is subtracted from a given value, we subtract its average and we divide by standard deviation. So if x is observation from a data set and its mean is mu and its standard deviation is sigma, then a new value is computed using a formula, and this standardization value is called as Z-score normalization. So in Z-score normalization, we use this formula. We use the original score, we use its mean, and we use standard deviation. You have been using log table. This is like a log table, a Z-score table. A Z-score, or we call a standard score, represents number of standard deviations a given value x falls from mean mu, and that can be computed using this or recorded using Z-score table. There are many different normal distributions, with each one depending on two parameters: the population mean mu and the population standard deviation sigma. Rather than performing computations on each new set of parameters for a variety of normal curves, it is easier to work in reference to the simplest case of normal curves called as standard normal distribution. And the process of converting the value from normal distribution to a value for standard normal distribution is called as standardizing and requires the use of Z-score from Z-score table. Let us consider this example. 50 randomly selected volunteers took an IQ test. Helen, one of the volunteers, scored 74 from maximum possible points, that is 120 points. And this 74 is the value x which is to be normalized. The average score is given as 62, that is mu, and the standard deviation is noticed as 11, that is sigma. Now, how well did she do on the test as compared to other volunteers? We can compute it using our Z-score formula. So convert a Z-score in order to find out of that is how well the Helen did using her IQ test points. So we have to convert her IQ test points to a standard Z-score using our formula. So we will substitute the values. X is 74, average is 62, and standard deviation is 11. So we get it as 1.09. Now to say something or to comment how well she performed as compared to other volunteers, we are going to find area corresponding to her Z-score. So after computing standardized score, we need to look up into an area that is same as a probability using a Z table. So for value 1.0, that is the value which we computed was 1.09. So we have to look at the row that is value 1.0 and here is 0.09. Wait, let me select other color. So at this row 1 and for the value 0.09, that is we are looking for the value for 1.09 and it is 0.8621. So what can we say? We can draw a conclusion. The area in Z table suggests that Helen received a better score than 86% of the volunteers who took the IQ test, because in Z-score table for 1.09 the value was 0.8621. So if you would like to know an exact number of people who Helen outperformed at the test, then just multiply 50 uh, by 0.8621, which results into 43.1. So we can say that as there are no partial human beings, we just around the number to 43, Helen did better than other 43 test takers. Z-score normalization, we can do it for some examples. We are given mu as 54,000 and sigma as 16,000, that is 16,000. So we can compute a value 73,600 using a formula which results into 1.225. We had computed this normalization for value $73,600 using MinMax Normalization 2, and now we have transformed into a new range using Z-score normalization that results into 1.22. So third technique which we have to learn is normalization with decimal. Let's learn third normalization technique, that is decimal scaling. Normalization by decimal scaling normalizes by moving the decimal point of a given value for attribute A. Number of decimal points that are moved depends on maximum absolute value of A. So for some value V from A, it is normalized to new value V dash by performing such operation. That is, we are going to use this formula. V dash is equal to V divided by 10 raised to J, where J we are going to compute from this maximum absolute value. So we are going to use the simple steps to normalize using decimal scaling. First of all, we are going to find the largest number among all attributes in the given table. Then we are going to count number of digits in the largest number. This is going to help us to compute J. And then we are going to put zeros equal to number of digits in the largest number. So let's look at one example. We are given numbers that range from 90 to 150. And now we are going to compute a new range for this 90 to 150 by using a decimal scale. So first step was finding the largest number in the range. So it is 150. Now we are going to compute number of digits in 150, that is for value J. So digits are 3. So J is going to be 3. So now we are going to divide each number by 10 raised to 3 and we will get a new value, that is normalized value. So 90 divided by 10 raised to 3, that is 90 by 1000 will give you 0.09, and similarly 150 divided by 10 raised to 3, that is 1000 will give you 0.15. So new range is going to be 0.09 to 0.15. Let us look at one more example. Suppose that the recorded values for A are ranging from -986 to 917. We have to consider maximum absolute value. So maximum absolute value is 917. So to normalize decimal scaling, using decimal scaling, we therefore divide each value by 10 raised to 3 as there are 3 digits in 917. So we will normalize it by dividing 986 minus 986 by 10 raised to 3, and we will divide 917 by 10 raised to 3 and we'll get a new range as point minus 0.986 to 0.917. This is one more example. Here we are given attribute CGPA and we have to check maximum value for attribute CGPA. Here maximum value is 3, so we can convert it to decimal by dividing 10 raised to 1, that is 10. So given values of CGPA are 2 and 3. So we will divide it by 10 and we'll get a normalized CGPA as 0.2 and 0.3. This is another similar example where we want to convert a salary bonus to new range. So we will look at the maximum value, that is 400. It has got 3 digits, so we will divide by 10 raised to 3 and we'll get new range, that is new values. 400 is mapped to 0.4 and 310 is mapped to 0.31. So we learned 3 techniques for normalization: MinMax normalization, ZScore normalization and decimal scaling. Note that there are some pros and cons associated with these techniques. Normalization can change the original data quite a bit, especially when we use ZScore normalization and decimal scaling. It is also necessary to save normalization parameters, that is parameters which we used, mean and standard deviation, so that in future we can bring it back or we can normalize it to uniform. So let us summarize what we learned. We learned that data normalization involves converting all data variables to a given range. And we learned 3 techniques for it: MinMax normalization, ZScore normalization and decimal scaling. Normalization can change a data quite a bit. And we have learned beginning in earlier video lecture, that was data preprocessing technique 1, and it is also used as one of the popular forms for data reduction. These are few assignments which are to be solved. So these are some questions from your question papers of university. You are given this, we have solved this question, and this is one more example. Here you are given values from 200, 300, 400, 600 and 1000, and you have to use MinMax normalization and ZScore normalization. These are some additional questions which are to be solved and submitted. And in next topic, that is in second unit, you have to learn about data warehousing, which includes topic operational database systems and data warehouses, and you have to also learn multidimensional data models, that is data cubes, stars, snowflakes and facts. And Madam Poonam Dholi has already uploaded video lectures for these topics. So this was all for today's video lecture. Thank you. Good day.